In this question, we're given the equations x squared plus y squared equals to 25, which is equation 1, and y minus 3x equals to 13, which is equation 2. We'll start off by picking equation 2, which is easier of the two, and we'll use the substitution method, which means that we have to rearrange for one of the variables, x or y. In this case, we'll rearrange for y because that's the easier one of the two. So we'll do it by adding 3x to both sides. So that's going to be y equals to 3x plus 13, and let me just label it star. Okay, so equation star is y equals to 3x plus 13. Now let's make a substitution. So substitute star into 1, right? Because we always substitute it in the other equation. The equation 1 goes x squared plus y squared equals to 25. Now we know y is 3x plus 13, so in place of y we're going to put 3x plus 13, right? So 3x plus 13 square equals to 25. Once again, it's x squared plus y squared equals to 25, but because y is 3x plus 13, so we do x squared plus 3x plus 13 square equals to 25. Okay, so now what do? Let me just use a different color here. So equals to 25. Okay, so we have x squared, and we need to expand 3x plus 13 all square. So we'll do it on the right side here. So 3x plus 13 all square is going to be 3x plus 13 times 3x plus 13. It's going to be 3x times 3x, which is 9x squared. Then 3x times 13 is 39x. 13 times 3x is 39x as well. And 13 times 13 is 169. So that's going to be 9x squared plus 78x plus 169. So in place of this expression, we're going to write 9x squared plus 78x plus 169. Okay, and that's all equal to 25 from before. Adding up the like terms, we get x squared plus 9x squared, which is 10x squared. Then there's 78x plus 169 equals to 25. Now there's 25 right here. We can take away 25 on both sides. So that's going to give us 10x squared plus 78x plus 144 equals to 0. Now notice that 10, 78, and 144 are all divisible by 2. So we're going to divide all three by 2. And that's going to give us 5x squared plus 39x plus 72 equals to 0. And that is the more simplified version of the equation, and that's easier to work with. Now, this reminds me of ax squared plus bx plus c, right? So, so remember, if you have ax squared plus bx plus c equals to 0, then you're looking for two numbers k and l such that k plus l equals to b and k times l equals to c. A times c. And now in this case, we're going to apply that concept on this. So we need two numbers k and l such that k times l should be equal to, k plus l should be equal to the middle number, which is 39, and k times l should be 5 times 72, which is 360, right? A times c is 5 times 72, which is 360. Okay, so let's get a pair of numbers. So for example, 1 and 360 multiply to 360, but they do not add up to 39, so we don't use this pair. Now 2 times 180 is again 360, but they don't add up to 39, so we don't take that. Notice that 1 plus 360 was a very large number, which is 361. 2 plus 180 was still a large number, 182. We only need a very small number, 39. Now, because these pairs are not giving us a small number, which is 39 in this case, right? They're giving us pretty large numbers. We know that down the road somewhere, we're going to find the pair of numbers that do add up to 39. But we can't try out all our numbers, right? Because these small numbers are not getting us anywhere. So let's try something big. Let's try something slightly big, not very big. So 10. maybe 10, right? Because we know 10 goes into 360, right? So 10 times 36 is 360, which is of course not the right pair because 10 and 36 don't add up to 39, they add up to 46, which is still quite close though, right? Because we made a big jump, we made a big improvement. So 1 add 360 was 361, 2 add 180 was 182, but 10 add 36 is 46, very small number, which is very close to 39. Now, the next pair of numbers that occurs to me is 12, and because 12 goes into 36, right? 12 times 3 is 36. So 12 times 30 should be 360. But this is still not the right pair because 12 at 30 is 42. Okay, so we're getting closer. Okay, so the right pair is going to be 15 and 24. So 15 times 24 gives us 360, and they also add up to 39. So this is the right pair. Okay, so using this pair, we can just take everything to the next slide maybe. So 5x squared plus 39x, right? So it's 5x squared plus 39x plus 72 equals to 0. And the two numbers we found were 15 and 24. So it's going to be 5x squared. And the two numbers we found were 15 and 24. So we're going to write 39x as 15x plus 24x. Okay, and plus 72 equals to 0. So we're gonna box the first pair and box the second pair. Okay, the reason to do that is because we're going to factorize the first pair and the second pair separately. So factorizing 5x squared plus 15x leaves us with 5x outside and x plus 3 inside. And then the other pair would be 24 bracket x plus 3. Okay, so the two factors are going to be x plus 3 and 5x plus 24, and they're both equal to 0. Now, the first factor gives me x is equal to minus 3, and the second factor gives me 5x equals to minus 24, or x equals to minus 24 over 5. Now, the two x values that we got, we're going to use them in our equation y equals to 3x plus 13. So this gives us y equals to 3 times negative 3 plus 13, and that is negative 9 plus 13, which is 4. Okay, so x equals to negative 3 and y equals to 4 is one pair. Okay, so that's one of the solutions. And then the other pair is going to be, well, it's going to be y equals to 3 times negative 24 over 5 plus 13, which is going to be negative 72 over 5 plus 13. Okay, and getting the common denominator gives us 5 on the bottom and 65 on the top. So it's going to be negative 72 plus 65 over 5, and that is equal to negative 7 over 5. Okay, so the other pair is going to be negative 24 over 5, comma, negative 7 over 5. Okay, so to take you back, the two solutions are going to be negative 3 and 4. So negative 3, comma, 4, and negative 24 over 5, comma, 7 over 5. Or negative 7 over 5.